Well, hello friends. Welcome back to Browser Hacking. Today, we are going to go and do whatever it takes to get the multi-process browser architecture stuff up and running in the browser proper. Because until now, the multi-process browser has been sort of this separate app, this WebView demo app, but I feel like it's finally getting to the point where we should make the regular browser app actually be able to use this for its tabs. Now, I think at the very least at first we will have two modes in the browser so that you can optionally run with an in-process web view or an out-of-process web view, right? Ultimately, the goal is, of course, to only use out-of-process web views. But for the moment, there's going to be all kinds of functionality that will only be available to in-process web views. So we'll make it an option. But yeah, so that's what we're doing today. And I guess, let's see. So until now, at least, everything that I've been doing for the web view, the multiprocess web view widget-wise, has been in this demo app here. So I'm thinking we probably want to move this thing into LibWeb, really. It's just that, I mean, yeah, this can move into LibWeb, and it will be a widget that you can instantiate from LibWeb. So let's see. Libraries LibWeb, and here we have the page view currently, which is the single process or the in-process web view widget. So we'll move the web view, web content view here. So these names are a little bit, they don't describe the fact that it's in or out of process web view. Rather, they simply discuss, or the only indication here that that this has something to do with the out of process thing is that it says web content, and web content is the name of the service that that this widget talks to. Anyway, I think that's still okay. So we'll move that there, and I think then we also have to make sure that we include these generated sources. So oopsie, we'll just copy this stuff over here. Generated sources, yeah, because we'll depend on a few more of those. So we'll do that. And we will also include web content view, CPP, and web content client, CPP. Okay, so these guys are moving into LibWeb, and then let's make the demo app here simply link against LibWeb. Maybe something like that. Okay, we can almost build it right away. We just need to say that this comes from LibWeb now. Let's just verify that the demo app still works. Oh, we got a crash. That's a weird one. Unrelated to this, of course. Okay, so the web view demo app still works. That's great. So I'm going to say this is a commit right here. LibWeb, move web content view into LibWeb. From demos web view into LibWeb. Okay. So web content view. So now what we want to do is we want to put one of these widgets into a browser tab. So browser tab currently has this right here, the page view, right? and this is the web page view currently. Now we want this to be, essentially we want to have either this or a web content view. We need to, I don't know, these names are probably not going to stick forever, but these are the names right now, so we'll live with it. Web content view, or maybe content view. Web content view, okay. And we'll just do this, web content view. So wherever we use this page view thing, we're going to have all kinds of things to branch on now. So here, when we instantiate a tab, we need to know up front, is this going to be an in-process web view or an out-of-process web view? So let's add a flag here for that. Type in-process web view, out-of-process web view. Maybe those should be the widget names, actually. I don't know. We'll see if we get acclimatized to these names. Type. And then we will slap the type here so that we don't forget. Okay, and then of course let us store the type in the constructor. So we don't forget. All right, so basically first step we need to take is when we instantiate the page view, we need to say if mtype is type in process web view, then make a page view. Otherwise, web content view is okay. So a lot of this is going to get really awkward now because we have all this code that calls stuff on page view. So one thing we do a lot is like load. So I think maybe what we'll have to do is we'll just add helpers here that like branch on the type of web view that we have, and then call the appropriate function. Because I mean, we could add like they could share a base class, I guess. I don't know if that's the right approach. We'll see. If this becomes like 100%, if this file turns into like 1,000 lines of like branching on the type, then probably we'll have a shared base class. But I don't know. We'll see. We'll see if that's what happens. So here, this will be something like if type is in type, then just call it on the page view. Right, like we don't want the whole file to be this. And obviously we need to actually include the web content view. Okay, so wherever we say page view load, we can now just replace that with load. So that should cover a bunch of situations already. And we already had this API. Oh, we did already have the API. All right, that's fine. Maybe I should just put the new implementation over the old one. All right. Let's see what else we call on the page view. So we have, what was that? Page view load. Oh, here's more page view load stuff. We just want that to be load. Okay. Page view. So we do a reload. That needs to be its own thing. And oh, this looks a little bit awkward. Let's just do that instead. What is a page view reload anyway? Because that just like take the current URL and load it again? Yes, it does. Okay, so I don't know. Maybe we don't need something fancy for that. Maybe we can just do like this. We don't have a URL getter. We should probably have a URL getter. Let's see. Is that a thing? Seems like that's a thing. Does the web content view know his URL though? I guess he doesn't. He could learn his URL. I'm just thinking, like, is reload really an action that requires us to like go into the engine and do a reload there, or could we do a reload at like the superficial level, or at like the widget level? But I guess since JavaScript APIs exist for like, what is it, like history.reload or something like that, the engine still needs to have some concept of reloading. So I'm a little bit torn, but let's not get caught up in this. So let's just say that that we have a way to fetch the URL from a web content view, and we add this API here, and then when we have nothing else to worry about, then we have to go and implement this. Okay. So we'll have load, reload, and Earl Kunst. All right. Cool. And then page view, back to this stuff again. See what else we're calling it on page view. So set focus. That one is sort of that's a GUI widget API. So it's really like view type agnostic. So really we could have something here like view, yeah, with just a view, and that would give you a GUI widget. So let's see, let's have a GUI widget view, something like that, because we always have a view. It's just that we don't know what type it is. So in this case, we return the page view. Else we no else after return. I feel like that's the thing I say most in review comments. It's like, please don't put else after return, because this stuff looks so goofy to me. Like, why nest your code when you don't have to? I feel like it's always better to have less nesting. It's just something in my brain like finds this so much easier to read when you return early instead of nesting. Anyway, so then we have a way to get to the view. That's great. And then we are setting up hooks. So let's see. This is some bookmark thing. Let's see. So this is like for bookmarking the current URL. So we can see here what it's doing is that it's fetching the URL by going via the page view, but really we don't need to do that anymore because we just added the URL API. But I guess we still want a string because it looks like that's what we're working with here. String, yes. Maybe those APIs should use URLs. I don't know. We don't have to deal with everything right now. Okay, so let's look for more page view stuff. So on load start, that's a hook. The hooks are a bit weird. I guess the hooks maybe are the one thing that's going to make me want to do the shared base class right away. So there's another hook. More hooks getting invoked. Hook, hook, hook. This hook we cannot really implement in the web content view. So the way the JavaScript console is implemented right now, it assumes that the JavaScript engine is in the same process as the browser application, and that's just not the case when you're doing multiprocess. So we're going to need to transport JavaScript console input and output like over IPC. So this will be a bit more involved to implement this. So I guess here we can say like if type is type in process web view. Fix me support. Out of process web view mode. And out in multi-process mode, yeah. Okay. More hooks. View source. Oh, that's an interesting one. So this one we can't implement right away for the multiprocess thing because we don't have a way to get the complete document source. We'll have to add a way to get that over IPC, but we can't do it right away. So we'll have to say like if type is, I guess, yeah. So this is what we're gonna do. We're gonna be like not implementing various things, and then we'll have to go and fill those in later. We'll say else to do. Oh, that's pretty good actually. We'll just use the to do macro. Okay, the DOM inspector, definitely not going to work in multiprocess right now. This will also require a fair amount of engineering to get that working. So again, here we will just we'll just do this, else to do. Okay. And blah, blah, blah. Maybe I should just copy this. Dumping the DOM tree and stuff like that. These are things that we can't do immediately because we can't access the document like this, but we could add IPC calls to implement this. So I think we'll do something like this for now. We'll just put like twos here. But these will be good things to add. Blah, 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 line box borders. Yeah, we can't do all this stuff. So many to-dos. Page view. And then more hooks, and then we're here. Okay, so really it's like all of these hooks. So now I'm kind of thinking maybe what we should do is we should just go and make a shared base class for all of these on foo hooks. What would that look like? So we are a scrollable widget, and we would be a web view hooks. You could do something like that. LibWeb web view hooks. Web view hooks. Public. All right. So it would be something like this, and I think this can probably be pretty bare bones. We don't need a lot of stuff here. We need to pragma once, and we should probably get the copyright header. Okay, I didn't write this 2 years ago. There we are, implicit instantiation of these templates. Okay, well, I guess I need to actually get function then. Whatever. Okay, so that's pretty cool. And then we just inherit from that, and then we can make the web content view inherit from that as well. So web content view will be a scrollable widget and a public web view hooks. I guess it goes in the web namespace. Yeah, the namespace situation we're going to have to do something about eventually, but right now this is what it looks like. And then we should actually get rid of those. Okay, so where are we instantiating the tab? Browser main. Where are we doing the tab thing? On line number 154. Add tab, browser tab, new tab. All right, so then we need to pass something here. So we're going to say tab or browser tab type out of process web view. Or maybe we'll put this in a variable here. Probably we're going to want a way to tweak this, obviously. Oh, right, that thing that we had to add when we had no more problems, the web content view URL implementation. So what if we would just be lazy and remember whatever URL that you loaded? So we could say, like, we store the URL like this. I guess we need to actually have the URL class. And then when you load a URL, we'll just say, like, oh, wait, hold on. Don't we get some notification about this? We get, like, web content client IPC. We have did finish load. Although we should probably, like, when we start loading, that's already the URL of the web view at that point. Let's be honest. So let's just store it then. Okay, and you don't like that on link. Wait, where are we now? Web content view 150. All right. So straight down here. This API. Oh, probably there was a difference between these APIs in the web page view and the web content view. So we'll just make them identical. So let's see. URL target modifiers. Yeah, just when you middle click a URL, we will now also give you the target and Control-Shift-Alt modifiers in the hook callback thingy. And now, what is the problem at tab CPP 199? On link middle click. Oh, I guess we have to just do this for the target and for the modifiers. Web content view URL. If this just works, I'm gonna be very happy. Wait, page view URL was fake? Page view reload. Page view doesn't have a URL function, it just has a declaration apparently, so we'll just implement it, no big deal. So let's see. Page mainframe document URL. Wait, that can't be signature. There we go. And then we can just do that. And then I guess we can even be a little bit nicer here and actually null check this. Yeah. And we are not allowed to connect to that socket. Okay, that's fine. We just have to unveil it. So we need to unveil the web content portal. There we go. That's good. That just means that it's working as intended. Okay, now something is null. In the browser tab constructor, all right, well, probably I'm doing something stupid, like calling something on mPageView. Of course I'm calling something on mPageView. Yeah, so really what I want to do here is I want to have something so I can go directly to the hooks, because hooks, we have the shared hook space class there. So let's see, mPageView on is going to become hooks.on. Poof. Okay. And then tab H. The hooks thing will be an internal thing, so it doesn't really matter where we put it. I guess here is fine. Web view hooks. Just thinking, where should we put this? We can, I don't know. Class web view hooks. Wait, this should be visible to me here, I would think, or actually no, it's not. Okay. Now we are just missing the implementation of hooks. Okay, great. So web view hooks, tab hooks, and then essentially this, right? No. All right, we started and then we died. So what's going wrong here? End of file on an IPC file descriptor. Web content client endpoint. Wait, what does that mean? EOF on IPCFD. Who's disconnecting us? Okay, so does it happen every time? Broken pipe? Wait, what? Server connection. So we see that the web content process at least starts up. So that's a really good sign. Then we get an assertion failure in server connection.h at 117. We're trying to write to the client, and the client, writing to the client fails. Broken pipe. Okay. I guess the client has given up way earlier than it should. Okay, so why is this happening? I wonder. So the web content process comes up and it gets told to load something, figures out what it is, all of that stuff, really, really good. But then what happens? Then it dies, I guess. But why does it die? Let's see. So now it would be good to see when processes die. I feel like I turned off so much debugging information in the kernel that now we can't even see when somebody dies anymore. So let's see. Let's log when somebody gets cleaned up here. So yeah, process debug. I think we can enable that. There's a lot of debug logging you can turn on if you really want to. Okay, ignoring that. Wait, now it came up. All right, well, at least we're up now. This is the multi-process browser view. Looking pretty cool. It's a little flickery when you resize, but who cares? We're multi-process. So let's open something like many buggies, and we crash. Okay. Clearly there's stuff to do here. So what is going on? We have a user space crash in 25. That's the browser process. Okay. So it's dereferencing a null pointer and the tab callback for title change. On title change. Oh yeah, so he's calling through on the page view. We can't be doing that, obviously. So I'm just scanning through here one more time. So, oh, I see. So if we don't have a title, if we don't know what the title is, but it says the title changed, then we try to use the URL of the open page, but then we know that we already have a helper for that, so we'll just use the URL helper. And oops, that should take care of that particular crash. Okay. So I don't know why this starts up nicely now after I turned on the logging in the kernel. That's a little bit alarming. So let's disable that logging and see what happens, because okay, so what kind of goofy race do we have here? Because this thing never crashes on startup, right? No, it doesn't. It works every time. But this guy, just no, no, no. And now we can't start up at all. Our connection to the web content thingy just totally fails because we can't write to the other side. But it's not that the other side dies. I am so confused. Oh. Just looking at our sockets we have going on here, just a bunch of RPC sockets. Nothing particularly interesting. Okay. This is very mysterious. So we know that we are definitely like sending a request to the web content process to start a load. So we've like done a handshake and everything. We're up and talking to each other. But then it dies down. That's okay. So why does it die down? We get epipe when we write because the peer is no longer attached. Sure. And I feel like I wanted the kernel to say, I guess we'll turn this back on. I wanted to tell me, maybe I can't see all the logging because apparently it's like too much. So maybe we'll only enable the logging that I actually wanted. So I just wanted to see when a process dies. That's the only thing I care about right now. So when we reap a process, and when it gets finalized, that's interesting. And everything else, let's just ignore. So hopefully that will be enough to keep the crash going. Okay, so web content dies. Great. Why? I mean, there's going to be something goofy going on in there. I would really like to see a stack trace. When we, let's see. Maybe we can just always dump, or we can be, oh dude, we can be even grosser. We can be like, if we're supposed to dump a stack trace, or if my process name is web content, let's just hard code that in the kernel. I just want to see why it crashes, or why it dies, or whatever. So, please tell us. So this is where we're exiting. Drain messages from server. Oh shit, wait, so web content talks to image decoder, and the image decoder hangs up on us, and that's why we die? That's so goofy if that's the case. So drain messages from server. So we get an EOF from the image decoder. Wait, no, this is in the browser process. Oh, dang it, I wanted to see the web content dying. Web content client. What? That's not the right thing. Okay, let's just dump out everybody's stack trace. Jeez. I just want to see the threads where they are when they die. Okay. Everybody's stack trace, finally. Okay, let's take a look. Web content, where are you? You are in server connection. So that's where you are, okay. But wait, no, this doesn't make any sense. This is the browser process. Okay, web content is here. Web content is calling sysexit. Why? Why are you calling exit, bro? Web content main. What does this thing do? It waits for a connection, and then it will run the event loop. And I guess if somebody nukes us from the event loop, we'll exit, but we really shouldn't exit. Okay, well, I guess since it was calling sysexit, we can just check. We can just put a stack trace in the exit function. There's probably a better way to do all of this. Dump backtrace. So we'll turn all of this back off. Process. We'll like undo all of that. And now we will get backtraces whenever somebody calls exit in the C library. So we're getting it in the image decoder. Man, I am so confused by this whole thing. Okay, let's not get too caught up here. So let's make some progress regardless. So let's add the hooks as a shared thingy between the two web views. So let's see. That and that, exactly. And likewise here. Yes, that, yes, that, yes, that. Not that, yes, that, not that. Okay. And this one is a bit tricksy. Okay. We can do this. I just want like one tiny little change in here somewhere to be added. It was the middle click thing, because the signature changed a tiny bit. Yeah, right here, this one. So split this hunk. Not you. Yes, you. Not you. Nope. Nope. Okay. Add a web view hooks, shared web view hooks base class for both web view widgets. This will make it easier for browser to share code between both views. Okay. And what did we change in page view? A whole bunch of stuff. Actually, we needed that change here as well. Right, so that one goes in the previous one. There we go. Okay. So what is up with this race? So what if we don't exit here? Then what happens? I'm curious. Like, does that... I feel like right now I don't even know why the web content process is exiting. Because like we definitely don't want to exit just because we can't talk to the image decoder process anymore. Like the image decoder is supposed to be like a throwaway process that you instantiate one, you send him some image data, he sends you back a bitmap, and then you don't care about the image decoder anymore. It can go away. If the image decoder crashes, I mean, in general, like in general, there needs to be a distinction, I think, between IPC peers that if they crash, is a disaster and we can't continue. Like if the Windows server crashes, we cannot continue being a GUI application at that point, right? Because we can't show a window if it crashes, and like whatever state we had in the Windows server is gone. But for something like the web content process or an image decoder or something like that, if they crash, that's sort of part of the purpose of those classes or those processes, is that we segregate their crashiness to like a separate process, and the browser needs to carry on even if a web content process crashes. So we really need to have like two modes or whatever for these things, so that we can say that like, oh, in this case, if the connection dies, it's over. But if, in this other case, if the connection dies, just let us know. Anyway, wait, what did? Okay, I got so sidetracked that I forgot what I was doing. Okay, so this is what happens. We get EOF on IPC FUD. Sure, lots of it. And presumably that's EOF on the web content FUD until it broken pipes on us. Yes. But I want to see where the web content exits. Where do you exit, bro? Image decoder goes down. Protocol server goes down. My gosh. Okay, well, let's see. What does this thing do? This thing constructs a new client connection object. Sure. What do we do with that object? Well, it's returned from here, but nobody takes it. But I'm assuming that we put it somewhere. In the client connection constructor, we add ourselves to a ref counting hash map. Sure, okay, so that's what keeps it alive. And then if the connection dies, we should probably say this, client connection die. This is web content, client connection die. This would tear down everything. It would make it exit in a friendly way. So is that what's happening? Wait, now it just started. Sure. And now you crash. Sure. Yes. Okay, so we are here. Web content client connection dies. So we're just exiting in a friendly way. A fully benign exit. Okay, so why is die getting called? Die. There's a shutdown. Or we get a client disconnect from, we get disconnected. I guess we can turn on this thing. And wait, oh yeah, we can do that. Shut down. I don't know. I just need to see what's happening. My cat is looking at me. Wonder what she wants. Okay. Dies because client disconnected. Web content, client connection, client disconnected. Ooh. So the browser has disconnected from us? I don't feel like it would do that though. I mean, I don't know. Is it lying to us? What causes a disconnection event? Event disconnected. Who sends this? Disconnected event, we do that if we try to read from the client and we get 0 bytes, or we get E again. Wait, train messages from client. I don't understand why it thinks that we have disconnected. And neither does Chilla. Okay, so let's see. I feel like I added some. This thing we don't want. We don't want this thing. Well, not right now, sweetheart. Okay. Well, I'll do that with you later on when I'm finished. She just wants to go out and sit in the wind. Yeah, I know. All right. Why is it this way? I feel like it's a little bit suspicious, this whole thing. Because if this is a non-blocking socket, which I assume it is, because we can get E again, right? So are we just getting E again? Is that what's happening here? Disconnected. E again. I don't know. Just something. Because like maybe we're just trying to read from a non-blocking socket when we shouldn't, and then we get E again, and then we're like, oh, we've disconnected, but really it's just that there's nothing to read for us now, and we're like reading it when we shouldn't. Well, just crash, bro. I mean, crash properly, please. Okay, crash. Disconnected E again, true. Okay. So I find this suspicious. Why are we getting E again true on the socket? Why are we trying to read from it then? If it is non-blocking. Let's see, so this is in a loop. And since we have bytes is empty, this is our vector, we've been accumulating bytes, so this would have to fail before we've managed to read anything. So we're in this function, we're in train messages from client, despite this non-blocking socket having nothing to read on it. So why do we think that we need to read from this? It's because socket on ready to read says that it's time to read. Why do we believe it's time to read? So the socket must be firing this hook. And why is that? So there's a read notifier for the file descriptor. So this we set up a notifier so that when we get a read event from the event loop on the file descriptor off this socket, then we'll fire this hook. Sure. So but read could also mean that it's disconnected. But if it would be disconnected, we would just get a 0. We wouldn't get an E again. So it's still connected. It's not E-offing, it's E-againing, and we're reading from it even though we're not supposed to. So this thing must be firing. nred is 0 or nred is even. Right. So maybe we should really dump a backtrace here, because this is the part where we're actually having the problem. Dumping the backtrace later is stupid, because maybe this can give us a hint about who's calling us and like why do we believe that the socket is readable. Okay, and so many things to read here. Web content, disconnected E again, true. Okay, so we're just in boring event dispatch. Right, so we're just dispatching an event, presumably firing this notifier, and can we call like, we have can read, what would that do? We'll call can read from file descriptor. This would do a select. So I'm just going to do this, can read, because I feel like this would be interesting to see if this assertion would fail anywhere. Man, it's like this type of stuff, it can be broken like anywhere, right? Because we control the whole thing. Like we control the kernel socket implementation in the C library and all of the wrapper classes and everything. Now it's not crashing. All right, please crash. Okay, here we go. Where is the... Oh, now we got this. msocket can read. It's failing. Indeed. So why are you failing? Okay, so okay. So what we're gonna do is we are going to say if msocket can, if it can't read, then we're gonna do something really goofy here. Go and look at file descriptor socket fd. I'm going to go and look at it in the system monitor to see what the heck it looks like, because we can learn more about that file descriptor. Because now I don't want to know what kind of state this thing is in. Because like, what the frick? This is probably some older bug that we're just surfacing right now. So file descriptor number 3 in the web content process. Actually, we'll need to get a root thing here. So web content, open files, this guy right here. This is our socket. It says that we can read and can write. Okay. That is indeed the state of that socket. And what about the browser? So here we're connected to, it says connected to PID 4 because like we connect to system server, which spawns the web content process. So this is actually kind of misleading here because our real peer is the web content process, but it will show like who initially accepted the socket, which was the system server. But we are connected to the web content socket. We cannot currently read from it. It's blocking on our side. And here it is non-blocking. And we can read. So I'm confused. Why does it think that we can read then? I guess we'll have to go and look in the kernel. So local socket can read. So in our case, it was an accepted socket. So either if we don't have an accepted peer, an attached peer, then we can read because that's an EOF condition. Yes. And if we have something for the server queued up, so like some data bytes, then it's also a can read situation. What the? So what happens if we just don't disconnect here? Like, I'm curious, like, does this actually matter? It would be nice if the kernel would include like how many bytes are queued up. So, oh, that crashes. Can go back. Sure. But ooh, what on earth just happened? We crashed the Windows server, it seems like. Okay, well, if I just don't treat that as a disconnection, then everything just keeps working. So clearly something here is very wrong, right? Because everything is actually fine. It's not disconnected. We're just treating it as if it's disconnected and then killing everything. This is so cool that like we're actually running JavaScript in a separate process and rendering it in the browser process. Very, very cool. Look at this. We have a process per tab. Let's make some stupid page. Wait, can I even open things here? I guess I could open like so let's see, if we make a silly loop, Oh, this is not going to end well if we do that here. Let's turn off the preview. So let's do an infinite loop like that. And then let's open this here. Permission denied. Oh, I can't. I guess because I'm web content, and web content can't look into this directory because it's not open to the outside world. But what if I would make it readable or executable to the outside world? Is that cached as a failure maybe? Hold on. We're gonna figure this out. No such file or directory. But it's right here. Okay. I'm not quite sure why this is not working. So let's make a stupid page here instead. This would be an infinite loop page. Infinite loop. Welcome to 8 infinite loop. That'll be the street address of this place. All right, very exciting. I just want to see what happens if we load this up in a tab. Like, res HTML misc loop HTML. All right, so this thing has loaded and it is executing the script, and it is very hung. And we don't show that in some nice way. I mean, you can see that the CPU usage is booming, but at the same time, we still have another tab here where we can just go and do our browsing stuff, hopefully. Come on, load Google. Okay. Is it loading? I think this thing is like murdering the CPU. Okay, what happened here? We got a crash. Oh, sure, yeah, we got a crash in the rendering because we can't render Google in the multiprocess case. But we're able to, let me see. This is working, so this is really awesome. Stupid infinite loop, go here. Yep. And I think if we kill this runaway process, where is it? Okay, this looks really confused. We have all these image decoders. Presumably they're like dead image decoders that need to be, that they're not shutting down correctly. Something to fix. But we have a web content process. I wonder who's actually the one who's running wild. Well, if we kill any one of these, then what happens? Kill. Oh, I can't kill those because they're not my processes. Crap. Okay. I have to be root. Kill all web content. Would that probably take down the browser? Yeah. And image decoder. Very strange state of the machine right now. Not exactly sure what's happening. Clearly stuff is still running, but that's beside everything. I think we just need a little bit of kernel work here to fix some weird issues. But this thing here that it tries to read from it and it thinks it's disconnected because of that, that's really weird. So this change is unrelated. I'm just going to push forward with commits. Anyway, so let's see. And let's make it default to the in-process web view at first. So let's see, blah, 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 blah. That's good. Fine, fine, fine. Also fine. Yep. 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 And yep. No. Nope. And yep. Browser plus LibWeb. Allow. Pave the way for embedding, for using using web content view in browser. This commit sets everything up, but it's not yet possible to choose a web content view to be. But we still always instantiate a plain web page view in browser tab. Okay, so I feel like there should be like a mode for this or something. How do we do this? Maybe you'll start the browser in multiprocess mode, so it has like it has one mode or the other, and like we don't allow you to mix and match at runtime. That would be at least easier. So let's just have some globals for that, like so we'll turn that off by default, and don't we have an args parser here somewhere? Yes, we do. Okay. We'll add an option, and the option would be G multi-process. Oh, I guess that's browser multi-process. Multi-process, and we can just have M for that. Cool. And then let's see, browser tab. We'll just extern this. It's a little bit gross, but whatever. Multi-process, and then when we create new tab. Wait, where were we creating the new tab? Is that not here? I'm in the wrong place anyway. Create new tab, it's right here. So here we can just do like multi browser G multi-process. If so, create the browser tab type out of process web view, otherwise in process. Okay, so this should allow us to run either like browser-m or just browser. And if you run browser-m, you'll get the multi-process mode. And if you don't, then you just run the old style, everything in one process. So this is everything in one process. Everything is normal. And then if you run -m, now you're in multiprocess mode. So some things may not work correctly, obviously. Like going backwards in history is apparently broken. As I'm sure a million things are broken. But it's good to have an option to start it this way. So browser, add a way to start browser in multi-process mode. You can now start. You can now browse in multi-process mode by passing -m on the command line. You can enable the new multi-process mode by passing -m. Yeah. Okay, that's great. And then we just have this mysterious race issue, which was not happening now. So it's an issue that we are painfully aware of, but it seems to be very flaky. And I'm not exactly sure why it's not happening now. But anyway, let's just ignore that for the purposes of this video, and it's something that I'll have to deal with eventually, but I just want to motor forward instead. So why is the location bar empty? That's what I want to know. Location box. Who sets the location box text? On load start. Okay. So I'm guessing that we're not firing any on load start hook. Page did start loading. Okay, so we just need to set that up in the did start loading. Yeah, we're not even listening for that that notification. So virtual void page did start loading. Okay. And page host. By the way, I made a little documentation page here about browser. If you go under documentation, browser, process architecture, you can see this little diagram of the process architecture and a little description of each process, and also a very basic class overview with a little description of that. I'm not going to go through all of it again here, but I felt like it's good to have this sort of thing to help me stay focused on what I'm trying to do, and also to help me communicate with other people about what I'm trying to do. So check that out if you're interested. Page did start loading. All right. So when we get this, we just want to post a message to our client. Say did start loading. Earl. Sure. And we will edit this. Did start loading. Earl. And did start loading. Okay. I'm getting a bit faster at just adding these like IPC plumbing interaction things. Although I'm much slower if I'm talking at the same time. But it's not so bad. Notify server did start loading. Message Earl. Okay, and we're almost there. All the boilerplate in the world. And Web content view. Notify server did start loading. If we have an on load start, apparently, then fire the hook. Ugh. Oh, I made a spello. I made a spello. All right. And now we die. That's the... I don't know why like the second time you try to run it, it dies even harder. It's very suspicious. This disconnection issue is so stupid. What the heck? I'm just gonna hack around this for now while we're testing. Very, very gross hack happening here, but okay, so now we have the URL showing up here. Very nice. Can we go backward? Yes, backward works. Forward does not work for some reason. That's a bit weird. So if I do this, I can go backward and then forward. Okay, so I wonder what makes the backward forward thing work. Go back. Go forward action. Set enable. History can go forward. Okay, so who determines that? It's if we have items in the history. Sure. And for items to show up in the history, we have to push items there, and we push on load start. So go back. Then we load history current. Okay, I don't know why that doesn't work, but I don't feel like tinkering with that right now. I'm just gonna add this hook here, the start loading hook. I guess LibWeb or web content. Plumb the page did start loading. Or hold on, let's say LibWeb. Make the web content view on load start hook actually work. Okay. Can we load the acid test? Yes, we can. That's really cool. Running the acid test in multi-process mode. Serenity website in multi-process mode. Very cool. My little page about sponsorship in multi-process mode. That's really cool. I got these scroll bars are always showing up. We should probably make it not do that. Also, it's burning CPU usage, burning CPU like crazy, but we can't solve everything at once. This is very, 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 very unstable alpha stuff, obviously. But it is interesting progress. So let's fix the scroll bar thing. Because it's weird that if we don't need scroll bars, we don't want to see them, right? So we'll just say like scroll bar, wait, is there some way to automatically... I feel like page view does something to make them automatically disappear or whatever. Yes, should hide unnecessary scroll bars. There we go. So that's what we want to do as well. Of course, that there's an interesting problem that arises with disappearing scroll bars in browsers, because like when you do the page layout, then your layout is completely dependent on how much space is available. And if you have a scroll bar, there's less space available. So your layout is one way. And then if you remove the scroll bar, then you have more space. So you have to, sometimes you have to do like a double layout to determine, first you determine if you need to have a scroll bar, and if so, you add the scroll bar, and then you have to lay out again because now the available width is different, for example. Anyway. Okay, so it looks a little goofed, but like, why is this here? I don't know why this is here. Probably we need some additional interaction with between the processes to make this work correctly. Because now he gets a little bit confused. Like, I don't know why it's doing this. Also, what's burning up all the CPU usage? Image decoder. Oh, is it because now we don't disconnect them? I guess that's probably why. So weird. I think I'm gonna, I mean, this is the behavior we want, so I'm gonna commit it, even though it makes it look a little goofy. LibWeb. Don't show unnecessary scroll bars in web content view. This behaves a little weird right now and will probably require more coordination between the widget and the web content process. Okay. Well, I think maybe we're gonna be done here for today, because I got a lot of good stuff done. It's clearly it's not you know, production quality yet, but it's now possible to run the browser in multi-process mode. It's very CPU burny and very broken in many ways, but on the road to greatness are many broken eggs. So that's nice progress. I'm happy with it. So if you made it this far, then I thank you for hanging out and watching this little video of me doing this, struggling with various things, and then finding some success in the end. I hope you found it interesting. I think this browser process architecture is super interesting stuff, and I'm glad to be able to share it with people. So thank you for watching, and I'll see you next time. Bye.